What is going on, guys? Welcome back. In this video today we're going to take a look at CuPy, which is a Python package that allows us to use NumPy on the GPU and thus allows us to speed up certain calculations. So let us get right into it. Alright, so we're going to take a look at CuPy in this video today. Now, as I already mentioned, CuPy is a Python library that allows us to use NumPy on the GPU, and it can lead to certain performance increases, to speedups when it comes to certain calculations and operations. It's based on CUDA, and what I want to do in this video today is I want to show you how to use it, how to use CuPy on a basic level, how to use it like NumPy, how to take NumPy arrays and move them to the GPU, do calculations, move them back to the CPU. And then I want to move on to the performance comparison. I want to show you how much faster CuPy is in certain situations, but also that it's not necessarily always faster, especially when you consider all parts that are involved in calculations. So we're going to explore that. You can see I have a bunch of images here and visualization scripts that I ran before recording this video. I want to explore the results there. But first of all, I want to show you how to use CuPy. So the first thing is we want to open up a command line and we want to install CuPy. So pip or pip3 install CuPy. You can either do it like this, or you can say install CuPy-CUDA and a specific version. So CuPy-CUDA 11x, for example, or CuPy-CUDA 12x. Now, interestingly, on my system, I'm using CUDA 12, but I still have to use CUDA 11x. I don't know why, but the package doesn't work with CUDA 12x. So I don't know why that's the case. The best thing is you try out for yourself which one works, either just CuPy, CuPy-CUDA 11, CuPy-CUDA 12. You can see what CUDA version you have by running the NVIDIA-SMI command, at least on Linux. You can see I have CUDA 12, but I still use CuPy-CUDA 11 because the other one doesn't work. Now, once you have CuPy installed, you can import it by saying import CuPy as CP, which is quite similar to NumPy as NP. And the interesting thing about CuPy is you can basically use it like NumPy. So you can go ahead and say array equals cp.array, and that's the same thing, that's the same thing as running numpy.array or np.array. And if you have auto-completion, you can type cp dot, and you can see that basically you have all the NumPy functions available. So that's one way to use CuPy, by just using it like NumPy. Another way to use it is to take a NumPy array like this one here and move it to the GPU, turn it into a CuPy array, so to say, by using the asArray function. So I can say carray, or actually let's call it GPU array, is equal to cp asArray array. That basically moves the array to the GPU. And you can do then matrix multiplication or whatever you want to do. And then you can take the result, whatever that result is, which is going to be a GPU array, and we can turn it back to a CPU array by saying whatever the array is as NumPy. So we're actually cp as NumPy, and we pass the GPU array in here. That turns it back into a NumPy array and moves it back to the CPU. That is already what you need to know about this. The rest is going to be a performance comparison. So what I have here is 3 visualization scripts, which are slightly different. It's not too important to read through all of the code if you don't want to. But basically what we're doing here is we're generating random NumPy arrays of a pretty high dimension. So these are matrices, n times n. We start with 1,000, we go up until 11,000 with a step size of 1,000. So we do 1,000, 2,000, 3,000, and so on. And what we do then is we move these arrays to the GPU. We perform a matrix multiplication using the dot method here, or the dot function. We do this one time with NumPy and one time with CuPy, and then we compare the time it takes to do that. Now, what you probably noticed here is this warm-up function. Now, this warm-up function, I have my mails open up, great. This warm-up function is basically a very simple operation just to get CuPy going, because the first time you use CuPy in a script, it's going to take some time to initialize. If you don't do a warm-up to initialize CuPy, you're going to skew the results. So I'm going to show you the result of this. This is what you get if you do the warm-up. You have the NumPy time, or actually the NumPy time is the blue one, so how long it takes in seconds to do a matrix multiplication with these dimensions here, or with this size here. You can see that it grows quite a bit, and we have more than 8 seconds when we get to the 10,000 size. And for CuPy, it's basically 0 seconds almost, so it's instantaneous. Doesn't matter what size we have here, it's very, very, very fast. If I don't do the warm-up, you're going to see something like this. So it's basically the same result, but the first time we do it, it takes some time to initialize, like around 1 second. And because of that, it seems in the beginning that NumPy is faster, but this is only because of the initialization, the very first time you run it, and then it basically doesn't have this overhead anymore, and you get the same result as before. Another thing here is, or one thing that you might want to consider is in the first visualization here, what I do is I convert the NumPy array to a CuPy array, but I don't consider that as work. So moving the array from the CPU to the GPU is not measured in the comparison here, which of course can be a problem because it's not faster if it takes super long to take a NumPy array and move it to the GPU to turn it into a CuPy array. So what I did then is I included that as the measurement here. So I did the same multiplication, or I did the same matrix multiplication, but I then also included the time that it takes to get the two arrays to the GPU and get them back from the GPU to the CPU. And when you look at that, you can see that the speedup is actually not there anymore because CuPy is now slower than NumPy because of this moving from the CPU to the GPU and back. However, this is only the case if you don't do a lot of work on the GPU. So for example, of course, if the time that it takes to move an array or multiple arrays from the CPU to the GPU is longer than the work itself, then it doesn't make a lot of sense. But if you have to do a lot of work, if you do a lot of complicated things on the GPU and the transmission of the result is just one array being transmitted, it can be faster. So if you have a lot of work to do on a GPU and very little data to transmit, it makes sense to use CuPy, and this is what you can see now in the last image here. After a certain size with a certain amount of calculations, CuPy is still way faster than NumPy. And the higher the problem size, the less you have to transmit, the less you have to convert from CPU to GPU, the more important this effect is going to be. So the faster CuPy is going to be if you do a lot of work on the GPU. But that is basically what CuPy does. It allows you to use the GPU for NumPy operations, specifically for matrix multiplications. This is very, very useful because the GPUs are optimized for that because of parallel computing. And yeah, this is something that you can use intelligently to speed up your NumPy calculations. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.